we still have the same learning goal. We're still working with those rational exponents. We're still working with all the other properties we have also to help us be able to simplify expressions that contain rational exponents. Well, today they're going to get, a little bit more complicated because we're going to be some operations going on, and we have to simplify correctly. And we're going to make sure that we do not skip. We're going to show lots of steps. We're not going to skip and say, well, I know that it's going to go to this, because especially in your notes, I want you to see how did we arrive at, how did we get to that simplified answer, because we're going to be using a variety of the different properties that we've already learned. Okay, so let's go to this first one where we have x to the 1/3 power being raised to the 3rd power. And then there's really an invisible multiplication dot right here that they just don't show. That is being multiplied by the 4th root of x to the 4th. Okay? So let's deal with our first factor, which is a power to a power. What do we do when we take a power to a power? What's our shortcut? I'm not gonna, I need to hear you guys. Aurora? Multiply them. What's the them? The exponents. We're going to multiply the exponents. We're going to show that. We're going to show that we're going to take x to the 1/3 times 3 power. We multiply the exponents. And then we're going to have a big multiplication dot down here that we're going to bring down the 4th root of x to the 4th. How can we rewrite that as a power to a power? What is the 4th root of x to the 4th written as a power to a power? No?
X to the 1/4 power to the power of 4.
Okay. You guys agree? No, you shouldn't. We're finding the 1/4 power of the base, the radicand, x to the 4th power. We're going to switch those two around. It's going to turn out the same because multiplication order does not matter, but we really need the 4 to be here. What's underneath the radical sign, our radicand, that's like our base here, that is being taken. When we find the 4th root, we're going to the 1/4 power. So that 4 and 1/4 need to trade places there, okay? Well, let's just work down now. This factor, x to the 1/3 times 3 power, what is a 1/3 of 3? 1. So this becomes x to the 1st power. Bring down our multiplication dot, and now we're going to apply the power to a power rule to this one also. 4 times 1/4.
4 times turn 4 into 4 over 1.
So that becomes, what is a 4th of 4?
1.
1, yeah. So that becomes a 1. So the other x to the 1st, there wasn't any more simplifying to do with it, so we just brought it down. And then when we take 1/4 of 4, we get 1. So that factor becomes x to the 1st also. And now we have a power times a power with the same what? Base. When they have the same base, what can we do with their exponents? Add them. So we have x to the 1 plus 1 power because they have the same base. So we just add their exponents. And what is x to the 1 plus 1 power? X
Squared.
X squared. There's our simplified answer. So we had to apply a variety of properties here. We did a power to a power. We did the, how do we find the root of something and then rewrite it as a power to a power? And then we ended up multiplying powers that have the same base, and we got it simplified to x squared. Anybody have any questions on that one? Okay, let's look at number 6. We have a multiplication problem here again. We have some multiplication going on there. We actually have some multiplication going on here. So that multiplication inside the parentheses, we call that a product. So we have a product to a power. What do we do with a product to a power? What is our shortcut for that? No?
We would take the 2 times 4.
Okay, so the x squared First of all, we're gonna give the x squared its own power of 4, right? When you have a product to a power, you give each factor their own exponent. So the x squared gets its own exponent of 4, and the y to the 1/2, you kind of skipped ahead, Noah, so I'm gonna back us up here a little bit. And the y to the 1/2 gets taken to the 4th power. That's how we start to simplify that one. We give each of them their own exponent of 4. How can we rewrite the 3rd root of y cubed? Michaela?
Can we just do Noah's shortcut we did last time and just divided those two?
No, we're gonna show this. So that we can show, because these are gonna get complicated, and I think we need to be able to follow down and make sure that we're simplifying properly. Okay? So, how can I rewrite the cube root, or the 3rd root of y to the 3rd power? Michaela?
Y to the 3rd of parentheses to the 1/4, or to the 1/3.
Yeah, to the 1/3 power. Y to the 3rd, the base, the radicand, is being raised to the 1/3 power when we're finding its 3rd root. Okay, now we'll apply the property that says we got power to a power in all 3 cases, don't we? So we're really going to take x to the 2 times 4. We're going to take y to the 1/2 times 4. And we're going to take y to the 3 times 1/3. We're going to show every meticulous, painful step. You do not have that many problems to do, so I want you to show this, that this is how you're going to learn these properties and be able to, on the quiz, when you don't have examples to look at that are exactly like the ones on your quiz, you're going to be able to say, but wait a minute, this is what's going on here. This is what I need to do. Hey, Devontae, what does x to the 2 times 4 power become?
X to the 8th power.
X to the 8. How about the next one, Devontae?
Y to the 2nd.
Okay, and how about the last one, Devontae?
Y to the 1st power.
Okay, do you guys all agree with it?
Yes.
Okay, so 2 times 4 is 8. Half of 4 is 2. We agree with that. And a 1/3 of 3 is 1. Okay. So what can we do next now? The next move is going to be Aurora.
And the exponents of y.
Okay, so here we, on these 2 factors that have y as the base, so the x to the 8th can't be part of that, can it? Because it doesn't have the same base. But these 2 factors, so right now we're really working with this right here. These 2 factors have the same base, so we can add their exponents. The product of powers. So in other words, they have the same base, so we can take that shortcut. So now we have x to the 8th times y to the 3rd. And would we see it in an answer bank with a multiplication dot between them? No, so we would really see this written as x to the 8th, y to the 3rd. That would be our final answer. Okay. Okay. So, I'm just curious, when you asked this question, can we use Noah's shortcut? How did our shortcut go? How did our shortcut go, Aurora?
We took the outside number and
We would call it Aurora. Go ahead and look on the front side. What did we do? Remember? Yes, we made this. We had this property. We decided we kind of had our own Noah's lucky property that you could divide. So when could you divide? So just the variable parts, right? Okay. So in this case, what did you want to divide, Michaela? I'm just curious.
3 divided by 3.
Okay, so this is the one that you wanted to do the 3 divided by 3 on, right here, right?
Yeah.
Okay, would it have worked? Is it, remember, we said as long as it works all the time. So what did we end up with y to the 1st power? Not down here, but did we eventually, like right here? So here, we could have done the dividing and would have gotten this to 1. Could have done it there. I'm just afraid of what's going to happen with using with there's so much going on in these problems like this, that we're going to think we can do that sometimes when we really can't. Because could we have done that here? Here's what I'm afraid you might do. You might think, I can take that 4 now and divide it by 2. And this should be then x squared instead of x to the 8. Can we do that? No, we have to multiply, don't we? So we, if we keep it all straight, but I'm just kind of afraid that that might not happen. So I guess, I guess we'll you make the call, but just be really careful then, okay? Okay, let's go on to number 7. We have a fraction, and we're going to have to simplify the numerator, and we're going to have to simplify the denominator, and then we're going to have to see if we can simplify that fraction after that. So we're going to do it kind of like by pieces. We're going to take that numerator, and we're going to rewrite that numerator as what? What can we do to that numerator? Noah?
X, take 2 times x to the power of 2.
Okay, so the x squared, there's really a multiplication going on here, right?
Yeah.
So the x squared is a factor, it gets its own power of 2.
And then y to the 1/2 power times 2.
And then the y to the 1/2 power gets raised to the second power. So we rewrite them, it's a product to a power, so we're giving each factor its own power of 2. Make a nice long or fraction bar, to make sure that you show that we still have a fraction going on here. That's what we're going to do upstairs. What are we going to do downstairs? How are we going to rewrite that? I need some new voices in here to come alive. How could I rewrite the 5th root of x to the 10th power? Faith?
X to the 10 in parentheses, and then to the 1/5.
Okay, do we agree with her?
Yeah.
Yeah. Okay, so now we'll move down to the next one and we'll say, okay, we still have a fraction going on here. We have x to the 2 times 2 power, and we have y to the 1/2 times 2 power, and downstairs we have x to the 10 times 1/5 power. Okay, so we applied the property of a power to a power, we multiply their exponents. So now what do we have? Upstairs we have x to the 4th times y to the 1st, because half of 2 is 1, over, what's a 5th of 10? Or in other words, if I have $10 and I'm going to divide it up equally 5 ways, how much money are you each going to get? $2. So it would be x to the 2nd power downstairs. Okay, are we done? We're done simplifying our numerator, and we're done simplifying our denominator, but now can we simplify the fraction? Yeah, we can, can't we? So in other words, when there's no addition or subtraction going on, we have just multiplication upstairs and we just have the one thing down. We can take these now and we can apply our quotient property. Our quotient property says, how do we divide? X to the 4th, subtract 2. 4 minus 2. So the upstairs exponent subtract the downstairs exponent. That's how we can do the division there. And then that y to the 1st is upstairs, and it's a positive 1, right? So can it stay there? Can it stay upstairs when it's a positive power? Yeah. So this is going to stay y to the 1st. What's x to the 4 minus 2 power become? X to the 2nd. Let's clean that up. What will that look like?
X to the 2nd power.
And just y.
And just a y, yeah. We don't need to have the power of 1 on it, do we? And we don't need the multiplication symbol. So there's our answer, x squared y. So do not try to do too many things in one step. Take here's what's going on. Here's the property that I can apply, the shortcut that goes with that property, okay? So that you don't get yourself in trouble and end up with the wrong answer. Because these are kind of hard to check to see if you would have the right answer or not. Anybody have any questions on that one anywhere along the way? Okay, what I want you to do is I want you just to do the first step in this one. I want you to write how could you start the numerator, and then do you need to do anything to the denominator? Do that also. And don't get carried away and do more than that. I just wanted to make sure we started correctly.
Just doing the numerator, right?
So the numerator would be the first one you'd want to handle.
Oh.
And then if you can do any simplifying in the denominator, then you would start that process also. Okay, Abby, what can we do to the numerator?
Take 8 to the 8th power in parentheses, and then 1/4.
Okay,
Times b to the 12th power in parentheses to the whole power.
okay. Calvin, what can we do to the denominator?
Leave it.
Leave it. I'd say the same thing. Leave it. Maybe stick a multiplication dot between them, huh? We could do that. We don't want it to feel left out totally. Okay. So now we say, okay, I have a power to a power and another power to a power upstairs. So I'm going to do a to the 8 times 1/4 power times b to the 12 times 1/4 power. And these guys downstairs are just happy to be left alone. Power to a power, we multiply. Clara?
Why would we put 1 over the 4, like we didn't do that for number 7 when there was a 2?
Number 7, when there was a 2, we didn't do what?
We didn't put a power of 2 on the outside parentheses.
So, because it was a power of, the one that was outside the parentheses that time was a 2, this time it was a 1/4. So, we just have to take their powers times each other. Sometimes the fraction is first and sometimes the whole number is first instead. I'm not sure I can answer that for you. Okay, what's a 4th of 8? 2. Okay, so we have a to the 2nd power times, what's a 4th of 12? 3. So b to the 3rd power. And we have a to the 2nd power times b to the 2nd power downstairs. Because there's no addition, no subtraction. Make sure you hear me on this because you can't make up new rules. Because there's no addition or subtraction going on in this problem whatsoever, is there? There's multiplication and division. Fraction bar means division. There's no addition, there's no subtraction going on in this problem. Because there is not, we can cancel. Is there anything here that can cancel?
The a to the 2nd power.
Yeah, those a's to the 2nd power cancel each other out. Anything divided by itself is 1. So that just becomes a 1 times our b's. And so when you multiply by 1, they stay what they, those b's are going to remain what they are. So now what we really have here is this b to the 3rd divided by b to the 2nd, which becomes b to the 3 minus 2, which is b to the what power?
Just
1
b.
power. And b to the 1 power is really just b. That's how we would see it in an answer bank. So that whole thing just became b. No.
What if it was b to the 2nd power over b to the 3? So
Okay.
subtract
So
3.
you're saying if it was this way instead, so this is what it was like?
Yeah.
Okay, you would still subtract it, you would have B2 minus 3 this time. And then that would become B to the negative 1 power. Can we leave it like that? Can't leave it with a negative power. How do we rename B to the negative 1 power? 1 over B to the positive 1 power, which becomes 1 over B. That would be our answer if that was the case. So we just have to follow the same, the same properties, the same rules, no matter what happens. In this one, it would happen that we would get a negative power, and then we'd have to just simplify it a little bit more. Okay? Anybody else? So that is not what happened. We don't read that in our notes, but that's what we would do if it did. Anybody else? Anything else that you're wondering?